A 2.52 gram sample of a compound contains only carbon, hydrogen, nitrogen, oxygen, and sulfur, and is burned in oxygen to find 4.23 grams of carbon dioxide and 1.01 grams of water. Another sample of the same compound with a mass of 4.14 grams yielded 2.11 grams of sulfur trioxide. Then again, the same compound with mass of 5.66 grams yields 2.27 grams of nitric acid. Calculate the empirical formula. So to find empirical formula, we need to find amount of moles of each element. And the compound was carried out a couple of different times. So we can say in total 100 grams of the sample, assume 100 grams of the compound in total, and figure out how much mass each of these made from 100 grams of that sample. So 100 gram sample times 4.23 grams carbon dioxide divided by 2.52 gram sample is equal to 167.86 grams carbon dioxide. The 2.52 gram sample made the 4.23 grams of carbon dioxide, and we're using that ratio for the total 100 grams of the entire compound. Then we follow that process for the other four components as well. So 100 gram sample times 1.01 grams of water divided by 2.52 grams sample. This makes 40.0 grams of water. Then we have 100 grams of the sample times 2.11 grams of sulfur trioxide over 4.14 grams of that sample, 50.97 grams of sulfur trioxide, and then lastly 100 grams of sample times 2.27 grams of nitric acid divided by the amount of that sample, which is 5.66 grams. And that comes out to be 40.11 grams of nitric acid. Okay, so now in order to find the formula, we need to find the moles. So then you can take each of these a step further and isolate for the element. Carbon dioxide can be isolated for carbon. So multiply this by the molar mass of carbon dioxide times 1 mole of carbon. And we find that there's 3.814 moles of carbon. Water can be used to find the amount of hydrogen. We find that there's 2.225 then times 2, so 4.45 moles of hydrogen. Then we do the same thing for sulfur dioxide, which we can isolate for S, sulfur. And then the last time would be for nitric acid. Whoops, we first have to take this into moles, molar mass. and that comes out to be 0.6365 moles of nitrogen. So we found the amount of carbon, hydrogen, nitrogen, and sulfur. However, we have not found the amount of oxygen. So we know that there's 100 grams of the sample, and we need to determine how much we have of oxygen. So what we have to do now is go back to grams of those samples. So we have, if we organize this, we have 3.814 moles of carbon times the molar mass. We get 45.866 grams of carbon. 4.45 moles of hydrogen times the molar mass of hydrogen. We get 4.486 grams of hydrogen. The moles of sulfur, 0.6366 times molar mass of sulfur, which is the molar mass of sulfur is, let's see how much sulfur is, 32.06. That is 20.416. Nitrogen, 0.6365 times the molar mass of nitrogen, 14.01 grams divided by 1 mole. And that's 8.9174. So we can say that there in 100 grams we have carbon plus hydrogen plus oxygen plus nitrogen plus sulfur, and solve for oxygen by subtracting 100 from the sum of carbon plus hydrogen plus nitrogen plus sulfur. We find that the mass of oxygen is 20.375 grams oxygen. Now, since we want the formula, we go back to moles and divide this by the molar mass of oxygen and find that we have 1.273 moles oxygen. Now we plug all of that back in. So our equation would look like this. Carbon, 3.814, hydrogen, 4.45, sulfur, 0.6366, nitrogen, 0.6365, oxygen, 1.273. We want the empirical formula, so we divide each by the lowest number, which is 0.6365. And the formula will be C6H7SNO2. So, finding the empirical formula, we want to find the amount of moles present in a whole ratio of each of the elements in the compound. We assumed that we had 100 grams of this compound, and these 100 grams were separated into 3 different experiments. The first experiment, from 2.52 grams, gave us carbon dioxide and water. The second experiment, using 4.14 grams, gave us sulfur trioxide. And the third experiment, using 5.66 grams, gave us nitric acid. So then, taking the ratio of the amount of each compound per the amount of that sample to 100 grams, we were able to determine the masses of each of these compounds in 100 grams of the sample. So then, using each of these components, we were able to isolate 4 of the 5 elements. Oxygen was in each one of these, so then we had to sum up the masses of each of the elements, subtract from 100 to find the mass of oxygen, then use the moles found by each, divide by the smallest to find the empirical formula.